Today we're talking about implicit differentiation. What that means is you have a function, let's say xy squared plus 2xy equals 6, and it's in an implicit form, meaning it's not solved for one of the variables, and you want to try to find dy dx or dx dy, either one. So how does this differ from finding the derivative of a non-implicit function or an explicit function? Well, basically, it's pretty much the same thing, except there's a little bit different procedure. And a lot of the times it's taught as if it's completely different, but really, it's actually just the chain rule. And I'm going to go over that. So if we want to find dy dx of this function, we basically differentiate each term with respect to x. So, excuse me, sorry. So let's start with this first term. The biggest thing to remember here is that y is not just, like, y isn't just y. Y is equal to a function of x. In fact, let me write that. Y is equal to a function of x, right here. So when you have this first term, xy squared, look at it as if it's x times a function of x squared, like that. So writing it like this, it's pretty obvious that you need to use the product rule to differentiate this. So I'll just keep that there for a second. So we're going to use the product rule on this first term. So it's the derivative of the first term, which is x, derivative of x is 1, times the second, and then plus the first times the derivative of the second. The derivative of of y squared is 2y, but we're going to have to add a dy dx, and the reason why is because, remember, that first term really looks like this. That y is really a function of x, like this. And if this right here, this term is a composite function, which means you need to differentiate it as such. You need to use the chain rule on this function. So you would do the whole thing. You would do the whole u is equal to f of x, and then du dx is equal to f prime, but f prime is really dy dx. So this is a huge thing, that y is really a function of x, and when you differentiate it, you have to use the chain rule on it to get the right answer. This right here is the core and understanding implicit differentiation. So I'll try to emphasize it more as we go along. So that would be the derivative of the first term. And then the second term, you once again use the product rule because y is a function of x, as we said before. So it's really the product of two functions. So if you do that, you're going to end up getting 2x dy dx, like that. And then you differentiate the right hand side, excuse me again, differentiate the right hand side, and you get that. Now wait, what happened? Why do I have an equal sign? Oh, get rid of that. So this is our this is what we have after all that. So now why does it have a 0? Hold on. Math program. There we go. I don't know what was going on. So this is what we have. Now basically all we do here is you just isolate dy dx. So we're going to move all the non-dy dx terms to the other side, so that includes this y squared. We're going to get rid of that y squared and put it on the other side. We're going to get rid of this 2y, put it on the other side. Then we're going to factor out this dy dx. like, oops, not fraction, like that. And now we could take this and divide it through, and we get this. And this is our derivative, and it's in implicit form, meaning we can't solve. It has both y and x in it, which is just fine. Sometimes you could solve it so it's just a function of x, but this is just fine. So that's basically it. Let's do another one. So we have xy plus x to the 4th y squared plus sine of xy equals x. Or no, let's just make that equals 5 or something. So this is the same logic. Basically, you use the product rule on the first one, so it's going to be y plus x dy dx, and that's because, well, you take the derivative of the first, which is 1 times y, plus the first times the derivative of the second. But remember, the derivative of this is the function. This is a function. Well, yeah. The derivative of this would be 1 if it was just like a variable. But remember, it's a function of x. So you're really writing this as that y is really f of x. So when you take the derivative, you can't just, it's not 1, it's f prime of x, which is dy dx. So you just remember that it's a function of x, not just a variable, I guess you would say. So that's the first, and then derivative of first times the second plus the first times the derivative of the second. Now we do the same thing with the second term. Derivative of x to the 4th is 4x cubed times y squared plus x to the 4th times the derivative of y squared, which is 2y, and then remember you have to do the chain rule, dy dx, plus now this one you have to do the chain rule on sine. So when you do your u, let's do some notes. U is equal to xy. Okay, so du dx is equal to, well, you once again have to use the product rule on this. So it's going to be y plus x dy dx. That's du dx, because this is actually a product of two functions. So when you do the chain rule, you're going to have to multiply this, and then this is going to be cosine of xy. So now, oh, and then equals 0 because the derivative of 5 is 0. So now we can move all the dy dx terms to the other side. We have this term right here becomes negative. We have a y becomes negative. This is going to be y times the cosine of xy. So, well, let's just distribute this through. Now we're going to move this to the other side. It's going to be negative. Now we can factor out this dy dx from all the terms. Just like this. Alright, and now we can divide by this whole thing on both sides. And we will have our derivative. And there you go. That's pretty much it. So the whole, that one is a little bit more complicated, but you just follow the rules. Yeah, every time, biggest thing people mess up is if they see an xy, they won't use the product rule on it. But really, you need to. And if you understand that y is f of x, you'll realize that there's really no other way. Like, you need to do it that way. So that's a big thing. Just remember y is equal to f of x, and you'll get this. Thanks for watching.